In a quiet support group room in Perth, Scotland, Joy Milne noticed what everyone else had missed. She had come beside her husband Les, expecting tea, sympathy, and the kindness of strangers. Instead, within minutes, the room offered her a recognition so strange that she nearly kept it private. The people around her shared a faint scent, one she had known for nearly 12 years. It was not medicine, furniture, damp weather, or imagination. It was something carried by their skin. Joy had smelled it on Les's shirts, pillowcases, and coat collars long before his diagnosis. Now, the same quiet trace seemed to rise from every person living with Parkinson's in that room. She leaned toward a nurse and chose her words carefully, because the truth sounded almost absurd. "Everyone here smells like my husband," she said, and the nurse did not laugh. That sentence would travel from a community hall to a laboratory and then into medical history. To understand why her observation mattered, we first need to understand what Parkinson's quietly takes away. Deep inside the brain, specialized cells produce dopamine, essential for deliberate movement. When those cells die, the body's instructions become blurred, delayed, and harder to obey. A hand may tremble, a stride may shorten, and a familiar voice may gradually lose its strength. The face can grow still, not because feeling has vanished, but because movement itself has become expensive. Parkinson's usually appears after 60, and roughly 1 person in 100 over 65 lives with it. It is the world's second most common neurodegenerative disease, surpassed only by Alzheimer's disease. Yet its visible symptoms arrive late, after years of damage have already accumulated beyond ordinary sight. By the first tremor, the disease may have been working silently for 10, 15, even 20 years. Earlier clues include disturbed dream sleep, constipation, depression, and a fading sense of smell. But clues are not certainty, and certainty has long been the missing instrument in Parkinson's diagnosis. For most patients, no single blood test, scan, or swab can simply declare the disease present. A neurologist watches someone walk, studies movement, hears their history, and makes a clinical judgment. That judgment may be excellent, but it begins after the body has started telling its story aloud. If Parkinson's leaves a scent before symptoms, Joy had found a doorway into those silent years. Joy met Les Milne in the early 1970s, when both lives revolved around a hospital in Perth. He was an anesthesiologist. She was a nurse, observant at work and attentive by nature. They married, raised 3 children, and built the crowded life that makes small changes easy to miss. By the mid-1990s, Les was only in his early 40s, yet little lapses had begun to gather. Joy noticed forgotten details, then colleagues noticed, until Les could no longer ignore them. Still, the change that unsettled Joy most was not memory, posture, or movement. It was scent. She later called it musky and oily, though never foul, nearly different from the man she knew. It felt less like a bad odor than a familiar portrait altered by one invisible brushstroke. She blamed soap, stress, hospital air, laundry powder, and other ordinary explanations. She changed detergents, washed bedding more often, and waited for the unfamiliar trace to disappear. It did not disappear because the source was not the house, the fabric, or anything she could clean. In 2002, at 45, Les finally received a diagnosis of Parkinson's disease. By then, Joy had lived with that unexplained scent in the privacy of home for more than a decade. Even diagnosis did not solve the riddle, because no textbook connected Parkinson's with a smell. The connection arrived years later, not in a clinic, but in that crowded support group room. Recognition came first. The room smelled like Les, and 12 years suddenly formed a coherent pattern. She did not announce a miracle, claim a gift, or ask anyone to believe her without evidence. She quietly pulled a nurse aside and asked whether anyone had ever mentioned this before. The nurse said no, but carefully wrote the observation down instead of brushing it away. Discovery often begins when someone treats an unlikely witness with patient, serious attention. Joy's words moved through the Parkinson's community until they reached researchers who understood the stakes. One was Dr. Thilo Kunoff, a Parkinson's biologist at the University of Edinburgh. Kunoff neither mocked Joy nor mistook conviction for proof. He chose careful science instead. He designed a small test that could fail clearly because such an unusual claim needed a clean answer. The question fit on a table. Could Joy identify Parkinson's disease by scent alone? 12 volunteers joined the experiment. 6 had Parkinson's disease, and 6 did not. Each wore a clean t-shirt for 1 day, then returned it for the blinded scent test. The shirts were coded, mixed, and laid out so that no visible clue could guide her. Joy leaned over each sample while researchers watched, carrying the claim in the silence between breaths. She placed one shirt, then another, into 2 groups, Parkinson's and not Parkinson's. When the codes were opened, Joy had identified 11 of the 12 volunteers correctly. The apparent mistake involved a control shirt, which Joy had placed with Parkinson's during the test. On paper, that choice looked like the ordinary error every tiny experiment is expected to contain. 3 months later, the person who wore that shirt received a formal Parkinson's diagnosis. The miss was not a miss at all. Joy had detected what the clinic had not yet named. The result spread through Scotland, then farther, because it was intimate and scientifically provocative. Yet 12 shirts and 1 remarkable nose could not establish a diagnostic test by themselves. The experiment proved only that the question deserved better tools, larger samples, and chemical scrutiny. So the mystery narrowed from whether Joy smelled something to what exactly she was smelling. That answer waited in the thin, ordinary layer of oil spread across human skin. The substance is sebum, the natural oil that helps keep skin flexible and water-resistant. Sebum is almost invisible, yet crowded with fats, proteins, hormones, and subtle metabolic traces. It carries faint records of processes unfolding deep inside the body, far beyond the skin itself. When disease alters cellular metabolism, the balance of those molecules can change in measurable ways. Some compounds remain in the oil, while others evaporate from skin as volatile organic molecules. Those airborne molecules form an odor signature, too faint and complex for most people to separate. Joy could separate it, not as a supernatural power, but as an extreme form of human perception. Roughly 1 person in 20 has unusually fine odor discrimination, though abilities vary widely. Perfumers, sommeliers, and dog handlers sometimes train similar sensitivity into a disciplined skill. Joy's results placed her much farther out, among the most sensitive human smellers scientists had tested. She distinguished closely related odors that most noses collapse into one undifferentiated impression. Researchers compared sebum from people with and without Parkinson's, searching for molecules behind her judgment. They found a reproducible pattern involving altered fatty compounds and other chemicals carried in skin oil. Joy supplied the biological clue. Chemistry began translating that clue into something a machine could read. Once scent became data, the discovery no longer depended on one extraordinary person being present. At the University of Manchester, Professor Perdita Baran's team pursued the obvious next step. If Joy's nose recognized a molecular pattern, perhaps an instrument could recognize that pattern reliably. Researchers collected sebum with a small swab across the upper back, where skin oil is plentiful. The sample entered a mass spectrometer, which separates chemicals according to their molecular weight. The machine reads peaks, ratios, and combinations, rather than impressions of musk or oil. The team trained its analysis on skin samples from hundreds of people, not 12 shirts. In published work, The chemical signature identified Parkinson's with accuracy, reported around 95%. The swab takes roughly 3 minutes, using a patch of skin no larger than a postage stamp. More important than speed, the method may detect disease near its earliest clinical stages. Earlier detection would not erase Parkinson's, and it would not make an uncertain future painless. But it could give patients answers sooner and place researchers closer to the disease's beginning. That matters because treatments may work best before extensive dopamine loss has already occurred. For Joy, the science carried a simpler meaning. 12 years of noticing had not been foolish. The detail, too private and strange to mention, had become useful to people she would never meet. Les died in 2015, but Joy kept working with the research team. She resisted describing the smell in detail, knowing frightened patients might search themselves and panic. Most people cannot detect it, and a vague resemblance could never equal a medical diagnosis. Her gift was never a home test. It was the question that allowed a real test to begin. Now a path runs from skin to molecule to machine, built from one woman's careful attention. Medicine advances when someone notices what seems impossible and someone else decides to listen.